Welcome to lesson 5-4. Today we're going to be graphing some ratios. So Ellen is shopping for supplies at Jake's party store. Make a table to show how much Ellen will spend to buy 3, 6, 9, or 12 balloons. Then we're going to do some graphing. So here we go. For 3, 6, 9, or 12 balloons. And the balloons are 3 for $2. So if I buy 3 balloons, it's $2. And 6 balloons, that's 2 groups of 3. That's going to be $4. This is 3 groups of 3, so that's going to be 6, and then $8 for 12 balloons. See, every group of 3 balloons was another $2. And so now we can use the X and Y coordinates to draw a line of all the possible costs for different numbers of balloons. And so when we had 3 balloons, it was $2. When we had 6 balloons, it was $4. When it was 9 balloons, well, that was $6. When we had 12 balloons, that was $8. We can keep going. We can see this is forming a line. Let's graph that. Looks like we have a line that goes something like this. And so this first question says, what's the coordinates of the point that represents the number of balloons you can buy for $6? So if I look at $6 and I come over and I come down, that looks like 9 balloons. So that is the point 9, 6. The next question says, how can you use the graph to find the cost of 15 balloons? Well, I come over here to 15 and I go up on my graph and it looks like it's $10. So we're going to find the y coordinate that corresponds with x equals 15. That's $10. And lastly, we have the original question from up top. It says use the graph to find the cost of 18 balloons. So if I follow up with the 18 and then over, it looks like that's $12. 18 balloons cost $12. Okay, now we're going to use skip counting or repeated addition to create a table, a ratio table, to help us answer this question. Jack, he's making juice, and he has 25 celery sticks, and if he uses all those celery sticks, how many apples would he need to make this juice? Well, let's make a table for this. So if we have 5 celery sticks, that's 2 apples. Now I'm just going to keep going up by 5s on this side. 5, 10, 15, 20, 25. And I'm going to go up by 2s on the other. 4, 6, 8, 10. Now I have a nice table I can use to graph my ratios. So here we go. When I have 5 celery sticks, I have 2 apples. When I have 10 celery sticks, I have 4 apples. And I can keep plotting all the values from my table. And connecting them, I get this graph. All right, let's look at part 3 here. We have diameters of different circular objects as compared to their circumference. And so just a little bit of vocabulary. A circle, the distance all the way around the circle, that's the circumference. And the diameter is the distance across the center. So if I have a diameter of 7 inches, which is what my fruit plate is, my circumference was 22 inches. The clock face had a diameter of 14 inches, and its circumference was 44 inches. And a hula hoop had a diameter of 35 inches, and its circumference was 110. You might notice these are all equivalent ratios. They're all 7 to 22 ratios if you simplify them. But we're going to plot these and get a graph of our ratios, our relationship between diameter and circumference, and use that to answer a question. So I'm going to make my x-axis, the horizontal axis, the diameter. And I'm going to make my y-axis, the vertical axis, my circumference. And I'm going to plot the 3 ordered pairs that I have, 722, 1444, and 35110. And there they are. Now I'm going to connect them with a line. And there's a graph of those ratios, and they're all equivalent ratios. Every equivalent ratio to those would fall on that line. Now for the second part here, it asks you to determine whether you can draw an object with a diameter of 10 inches and a circumference of 50 inches, because any circle is going to have that same equivalent ratio. So look at the graph, look at where 10, 50 would fall, and see if it's on that line. Go ahead and take your best crack at it, and we'll talk about it in class. Okay, we got some straight up practice. We got a ratio table here, and you can see a pattern. You can do some skip counting to complete the table. We got 3 to 8, 6 to 16, 9 to 24. We're going to keep going up by threes in the number of boxes and find the equivalent ratio of the cost. Give it a try. And then we have some equivalent ratios, 3, 4, 6, 8, 9, 12. We're going to graph them. We're going to use the graph to find the number of nonfiction books purchased if 10 fiction books are purchased. So go ahead and take care of that, and we will talk about it in class. Take care.